All right, welcome to section 1.3, new functions from old functions. So again, some more review from your algebra and pre-calculus classes. Let's see, so transformations of functions. So transformations, if you remember, that's shifting, right? So you can shift a graph up, down, left, or right. What you want to remember, and I'm going to go over this section a little quickly too because it is review. This is the stuff you want to remember right here, okay? There we go. All right, so what you want to think of, so if we're going to add some value, so C is just some constant positive number. If we add a constant value to the function, just think, remember, f of x is the same as y, right? So what you were doing is we're adding numbers to the y values, which means we're going to move upwards, right? Because on the y-axis, if you add to the y-axis, you're moving up. You can use that same thought process here. If you're going to subtract a value from the y value, then you're shifting downward. Now, the shifting left to right is a little bit weird, if you remember. If we're going to subtract from the x value, so the key here is that the x, or that the constant's being subtracted from the x inside the parentheses. That's the important part here. If that happens, we go the opposite direction. If we're subtracting, we're going to move to the right on the x-axis. And if we add, we're going to move to the left. So remember those two. Those are important. It's kind of the weird ones. X is the weird one. It goes the opposite direction of the sign. Okay? And again, all that does is just shift your graph up, down, left, or right. So make sure you are familiar with these kind of transformations. Stretching and reflecting, very similar, right? But we're going to do some multiplying for stretching and reflecting. So this one you should know as well. So if we multiply a constant times the function, right? So think about what we're doing is we're taking some value and multiplying the y values by that number, right? So you're going to stretch vertically. If you multiply a y value by some positive number, especially in this case it's greater than 1, right? If you're going to multiply by a number greater than 1, then you're going to increase that value. So it would stretch on the y-axis vertically. If you multiply by a fraction, right, so 1 over some constant, you're going to shrink the graph, right? So, if your y value is 4 and you multiply by 1/2, that cuts the y value down. It's going to shrink it. All right. Then very similarly, if we multiply the x by some constant, you stretch horizontally, sideways, by a factor of c. Shrink. Remember, x is the opposite. And then if we divide by some c value, if we divide the x by some c value, you're stretching the graph. Putting a negative in front of the function flips about the x-axis, because in other words, they're telling you take any y value and change its sign. So if it was above the x-axis, it now goes below, and vice versa. Now if we multiply the x value by a -1, we're reflecting about the y-axis, because again, you would take any positive x value, now make it negative, or any negative x value and make it positive. All right? And there's just some graphical representations here. So this is good stuff to look over. It should be pretty second nature to you by now anyway, but it's good to look at. All right, so let's look at these different transformations here. So we're going to use the basic graph y equals radical x. So that's that graph right there. Use transformations to match the following graphs. All right, so let's look at the first one. So A, we're taking the function and subtracting 2. So that would bring the whole function down by 2. So there we go. There's A right there. We're taking that original graph and bringing it down by 2. B, we're subtracting 2 from the x. So remember, when we subtract from x, we're actually moving to the right. Okay, so this is graph B. C, we're taking the function, multiplying by -1. So we're taking any y values, making them negative, right? All right, so that would be this one here. Part D, we're taking the function and multiplying by 2. All right, so we're taking the y values and doubling them. So what that's going to do is it's going to stretch the graph upwards. So there's D. And the last one here, E, we're taking the x values and multiplying them by -1. So we would take any positive x value and make it a negative x value. So there we go. There's your graphs. Okay? So again, make sure just go over this stuff, have the basics down. We'll do a few more things on this lecture here. Combinations of functions. So two functions f and g can be combined to form new functions. We can add, we can subtract, and we can multiply, and we can divide. Okay? Some and different functions are noted by this. So this is a notation issue here. So if you see f plus g of x, it's the same thing as saying f of x plus g of x. Okay, it's just notation. Again, make sure that you're very familiar with function notation for calculus and beyond. It's extremely important. Very similarly here, f minus g of x is the same as saying f of x minus g of x. Of course, for this one, for the addition, the order does not matter, but for subtraction, order definitely matters. All right. If the domain of f is A and the domain of g is B, then the domain of f plus g is the intersection A and B. So remember, intersection means the overlap. All right, so if you're going to add or subtract two functions, the new domain, after you added or subtracted, is the overlap, the intersection of the original two domains. All right, so let's do some problems here. So find the domain of f of x equals radical x, and the domain of g of x equals 2 minus x in interval notation. All right, so this one here first, radical x, the domain. You've got to think about these domains. You don't always have to memorize things. Sometimes it's better just to understand. Right? If you're taking the square root of something, of course we got to assume we're in the real plane. Remember, you're not allowed to take the square root of a negative number in the real plane. But are we allowed to take the square root of 0? Sure, right? The square root of 0 is 0. And are we allowed to take the square root of any positive number? Yes, of course, right? So we're going to say the domain is 0 included to infinity. All right? Okay, so the next one here, g of x. Now they want to know the domain of radical 2 minus x. So there was a little trick you were hopefully taught at some point in your algebra or pre-calculus classes. The trick here is you take what's under the radical. So we're going to take the 2 minus x, and just as we talked about here in the first one, we know whatever we put under the radical must be greater than or equal to 0, right? So greater than or equal to 0. Now we can solve this, right? We could add x to both sides. All right? So now be careful when you read this, right? Usually you want to read an inequality from the variable to the number. It's just easier for us to understand. You can read it either direction, but to understand better, read from the variable to the number. In other words, this would be x less than or equal to 2. Okay? But they want this in interval notation. All right? So less than or equal to 2, so the domain is, we're going to go from negative infinity to 2 included. Because if we throw a 2 in here, we get a 0, and we said that's okay. All right? Okay, so then find the domain of f plus g of x. All right? So we said before, right up here, the new domain is the overlap of the two original domains. So this one's pretty easy to visualize, but let's graph it just to see it, right? So let's see, we have 0 over here, we've got 2 over here. So let's graph these. So the first domain from radical x was 0 included, so solid circle, to infinity. The domain of radical 2 minus x was negative infinity up to 2 included. So we'll solid dot the 2, and the arrow goes that way for less than. So the overlap is right here between 0 and 2. Of course, we're going to be including 0 and 2. All right? So there we go. So the new domain of this guy right here, the domain is 0 to 2 inclusive. Okay? All right. Similarly, the product and quotient functions are defined by the domain of f times g is a and b. Okay? So again, the overlap. But we can't divide by 0. All right, so the domain of f divided by g is the intersection such that, so if you remember your notation, that bar means such that g of x cannot be 0. In other words, your denominator cannot be 0 because that would be undefined. Okay, so that's important to remember. Let's see, so let's do another example here. Find the domain of f of x equals x squared. So quick review, x squared, we should know that. That is a parabola, right? With a vertex of 0, 0, facing upwards. Okay, it's good to review these things. All right, so let's see. So the domain, this should be second nature by now, the domain of any up or down facing parabola is always all real numbers, right? Okay, but again, we're following directions, interval notation. Again, remember, with infinity and negative infinity, you always, 100%, always use parentheses on your interval notation. Oops. There we go. For g of x here, 1 minus x, so that should be recognized right away as a linear function. So our y-intercept is 1, our slope is negative 1. Okay, so quick graph on that, super quick graph, we can do this. It's not going to be necessarily to scale here. Let's see, we have y-intercept of 1, negative 1 slope, so down 1 over 1. So we're going to get a graph that looks something like this, right? That's a quick draw, no, don't worry about scale here. What is the domain of any non-vertical line? Same thing as the parabola, right? Negative infinity to infinity. Okay, so let's find the domain of f divided by g of x. All right, so the parabola divided by the line. Now there's a little thing we got to be careful of here, right? We said before when we add or subtract or multiply, the domains are just simply the overlap. The domain of the new function is the overlap of the original two domains. Well, in this case, the overlap would be negative infinity to infinity, but we have a denominator here. We have to exclude any value that would put a 0 down there. So, and I know this one's very easy, but I'm going to remind you of the process. The process is we take the denominator to find the domain, or well, to find the restrictions on the domain of a fraction. We take the denominator, set it equal to 0, and solve, right? Well, this one's easy, x equals 1. So what we really want to say for the domain is that x is not equal to 1, because if we plug a 1 in there, we get a 0 in the denominator. So what that means is our new domain is the overlap of the original 2 minus anything that would give us a 0 in the denominator. So the way we write that, we're going to say from negative infinity to 1 not included, right? We just said we're excluding 1. Union with, so it means put it together with 1 not included to infinity. Okay, so there's your new domain. Another way to state this new domain is all real numbers except 1. Okay? Alright. Alright, so we can also compose functions. So remember your notation here. That little open circle means of, so f of g. Another way to write it here, f of g of x equals f of g of x. So the way you want to think about these is if you're doing any kind of work on them, take the x value, plug it into the g function. Whatever answer you get, you plug into the f function. Okay? So the domain of the composed function f of g is the set of all x in the domain such that g of x is in the domain of your function. In other words, f of g of x is defined whenever both g of x and f of g of x are defined. The figure to the right shows how to picture f of g in terms of machines, so it's a composed function. Alright, example here, if f of x equals x squared and g of x equals x minus 3, they want us to find f of g and g of f. So in these composed functions, remember that symbol is not multiplication, it's composition. And we have to follow the right order. So what we're trying to find is f of g of x. We could rewrite that as f of g of x, which means take the g function and plug it into the f function, right? Okay, so the g function is x minus 3. We're going to plug it into x minus 2. But be careful. You need to have parentheses because we're taking this g function and replacing the x with x minus 3. Okay? So you could FOIL that out if you want, but it's not necessary. Let's do g of f. So g of f of x equals, we could also write it g of f of x, and again that means take the f function, plug it into the g function wherever you see the x. So really all we're going to do is replace that x with an x squared. And there we go. Nice and easy. Okay, make sure you go over this section. It is important stuff you should know, but it's always good to see it again. This last little bit here is just simply saying we're not limited to composing only 2 functions at a time. We can compose as many as we want, but it's the same process, right? Again, if you were going to solve this or work with it in some way, we would take the x value, plug it into the h function. Take that answer, plug it into the g function. Take that answer and plug it into the f function, etc. Okay? Alright, so again, go over this section. Make sure you know this stuff. Thank you for listening.